In this video, we're going to be calculating slopes using a map. So there's quite a few steps that are involved in doing this because we have to deal with elevations and we have to deal with distances. So I'm going to start with doing a going between 2 points. And I'm going to start with a point that we know, and then there's going to be a point that we interpolate, and then there's going to be the distances and so forth. So coming down to the map, we are going to we're going to go from Sentinel Peak, which is right here, and then we're going to go to, there's an intersection of Coral Creek that is right, oh, that's the wrong one, it's right here. So we're going to go to there. So that means that my line that I'm going by is along here. Maps are meant to be drawn on, so that's what we're doing. It appears that I have another line that I've drawn on right here. So, anyway. So, Sentinel Peak, we're going to kind of split this up into elevations and distances, because then we can deal with them separately. So Sentinel Peak is 7,785 feet high. You can just keep it down there. So 700. Sentinel Peak. Then I'm going to go to the point that I just identified, which is over here. Now, if you look really closely, you're going to see that there is the 5,000 foot contour here, and it actually wraps around that point. So I'm going to assume my interpolation, even if I split it in half, if it was perfectly in half, then I could say, yes, that is, it might have been 4,950. But because the 5,000 elevation comes around and wraps around it, I'm going to assume 5,000 for my value. So we can come up to the board here. And so we know 5,000 feet is my creek intersection. So I'm going to go from Sentinel Peak to the creek intersection. So that means that I have to use the difference where I go to the point B minus point A. So you always go ending minus starting. And the reason is because of the negative. So we have to be concerned about that negative. So we're going to say 5,000 feet minus 7,785 feet. And this gives me negative, I'm going to, should be 270, but I'm just going to make sure before, because I haven't had to do math all summer. Yes, 2,785 feet. Now, if you guys did that in your head, you should have been able to do that in your head because that is really simple. I'm overthinking things at the moment. So this is my elevation change. Now that I know what my elevation change is for my slope, I need to know the distance, and the distance needs to be in ground distance, not just what's on the map, because the map is scaled. So now we can go back to the map, and we're going to deal with the scale. So I'm going to use my measurement, and I'm going to go from Sentinel Peak to my intersection, which I've drawn out, and it is exactly 12 centimeters. So it's this point. So I have 12 centimeters, and my scale is 1 to 50,000. So to calculate my ground distance, I have 1 over 50,000, which equals my dm, which is my distance on my map, divided by my ground distance. So I go 50,000 times 12, and this divide by 1, and that gives me 600,000 centimeters, which equals 600 meters. 6,000 meters, sorry, 6,000 meters. So that's my ground distance. So now we're going to wait for the dogs to pass. And then we're going to do the calculation. Although we have a problem. This is in meters and this is in feet. We have to have the exact same unit when we go to do this calculation. So therefore we have to convert feet to meters. And there are many different tools that you can use to do that calculation. And so I am just going to use my calculator because that's what I use. So do that, and then I'm going to convert it to meters. So this equals negative 848.868 meters. So using that now we know that slope equals rise over run, which is my elevation over my DG. So now I can do negative 848.868 meters divide by 6,000, and I get a value of 0.1415. Now if I wanted to get a percent, which I will ask, I will tell you if I want a percent or if I just want you to leave it as a slope. Generally we kind of leave it as those values if it's dealing with a line, or if we're going to do math with it later. But so this answer becomes 14.15% slope. And that is how you do it on a map. The end.